Hey everyone, Gregory from Runtime Verification is here. Here we have Raoul. He's a formal verification engineer at Runtime and also the core developer behind Simbolik. Before we dive into our debugger introduction, can you please tell more about yourself and your experience, Raoul?
Yeah, sure. Thank you, Gregory. My name is Raoul, formal verification engineer at Runtime Verification. I spent thousands of hours securing smart contract protocols, DeFi protocols for the Ethereum ecosystem, from design reviews through code reviews, through formally verifying critical code paths and protocol invariants. And nowadays, I'm leading the Simbolik debugger team at Runtime Verification.
So we are getting very close to the launch of Simbolik. And Raoul, I think you would be the best person on the team to introduce this tool. So what is Simbolik? What is it about? What does it do?
So on a very high level, I would say it's a Solidity debugger that has all the classical features you would expect from a debugger, like setting breakpoints, stepping through the code, inspecting the storage, inspecting the memory. It was born out of I was a bit frustrated with the availability of Solidity debuggers out in the space. So especially if you're doing, if you're a security-minded person and you're doing security reviews, you're reading lots of code, and it's common wisdom that reading code is much harder than writing code. And we have good tools for writing code. We have Visual Studio Code, which is a fancy editor, but we don't have any good tools like that support you while reading code. And to elaborate a bit, why is reading code so hard? Well, why is reading code harder than just reading a fiction book? That is, while you're reading the code, you're mentally executing it, and you're building up this huge mental model of all the possibilities and of all the keeping track of all the variables, keeping track of the call stack. And I find myself doing this a lot mentally, and then an email notification popped in and my mental model just vanished. So I then did this on pen and paper. I just diagrammed the code base with a pen and paper. I executed it literally line by line. And then when you do that for half an hour or an hour, you start losing confidence that what you're doing is actually following the rules of Solidity and EVM. So then you spend 1 hour of work following a single code path, and then you throw it all away because you lost confidence at some point. So, and that is where I felt, well, this task of executing the code is actually something that computers are really good at. And then I wanted to automate this. And we started brainstorming, and then we thought, well, we don't need to reinvent the wheel. What we are looking after is just a debugger. So we looked for debuggers, but we were kind of unsatisfied with the existing tools. So that's how we ended up developing our own Solidity debugger.
Awesome, thank you for introduction. So in technical detail, can you please describe how Simbolik works?
Better than explaining, I can just show you. So let me...
That's even better.
Share my screen. At a very simple example, that was chosen precisely because it is so simple to follow. So we are looking at a simple ERC20 contract, and that ERC20 contract has a bug in it. And in this demo, we try to identify this bug. I won't tell you before where the bug is, just to say we have seen that in the wild. We have seen that in contracts we audited. We have seen this on code contests on Code Arena. So this is a classical ERC20 token. It has all the classic functions: transfer, approve, and transfer from. And then we have this wrapper contract, which is debug ERC20, which we can use to initialize our debugging session, right? So if we want to debug this contract, well, we must specify the function parameters. Like if we want to debug the transfer function, we must say, hey, what is going to be the value of this to variable? What is going to be the value of this other variable? And instead of coming up with a custom user interface, we thought, well, your configuration, your debugger setup should just be code. It should just be Solidity. So that's why we have this other wrapper contract debug ERC20. And you see we have these parameterless functions. And specifically, we have this debug transfer self function. And you notice that there's a debug button showing right above the function. And we use that button to just initialize the debug session. So this button will show above all public and external functions, provided that the function does not have any parameters. Like again, if you want to debug a function with parameters, you have to wrap it in a parameterless function. So I'm just going to start the debugging session here. You can see that it automatically starts compiling my contracts. And when it's done, it automatically deploys the smart contract to a local test net. And then it stops at the first operation of the smart contract. So in this case, it stops even before it enters into the debug transfer self function. That is because, well, Solidity smart contracts, they have kind of a setup code that runs before you actually enter the functions. So let me just jump directly into the function. I'm going to jump into line 27. And what you can see now is on the top left corner, I can inspect my smart contract state. So I can see what is my current program counter, what are the values on top of my stack, what is the memory, what is the storage, and what is the return data. So all these memory regions of the underlying EVM are directly observable in this debugger. What you will notice is that you cannot see directly any Solidity variables in this view, and that's because it's still work in progress. But the goal is ultimately to have a full-fledged Solidity debugger that also allows you to look at Solidity variables, not just at EVM data structures. So I'm going to execute over this line, and let's observe the stack. So this line is looking up the balance of the message sender. I'm going to execute over it. And you can see that the top value of the stack becomes 10,000. And if we look at the constructor, we see that we initially minted 10,000 tokens to the contract deployer. So this is us right now. This is where these 10,000 are coming from. Then I'm going to transfer 1,000 tokens with the next line to myself. And while I'm doing that, I can just jump over the function, but what I want to do actually is now I want to jump into the function. I want to see how is the function under the hood actually executing. So I'm going to jump into this function. It brings me to the transfer function of the broken token that I showed you before. And then I can start executing over this function. So here I'm just recording, hey, what is the balance before? What is the balance of the receiver before? Now I'm doing the internal accounting. In this line, I'm going to debit the sending account. In the next line, we are going to credit the receiving account. We are emitting the transfer, and then we are just returning. So I'm going to jump out of this function again. And now in the next line, I'm going to record the balance, my current balance. So, and at this point, you can even see on the stack, well, that the balance that I had before and the balance that I have now, they are not the same, like they are different. So before I started with 10,000 tokens, and now after doing a transfer to myself, I ended up with 11,000 tokens. So I just created 1,000 tokens out of thin air. So that is the bug that we can see here now. And because I'm aware of this bug, I also put this assert statement here into the transfer function, and can see that I'm asserting, hey, the balance before should be the same as the balance after the transfer if I'm just transferring to myself. So, and if I'm going to execute over this statement, you can see that the contract actually errors out or reverts, and it's pointing us here to some intermediate generated YUL code that was generated by the Solidity compiler actually. But you can see in the call stack, you can actually see that this transfer happened inside the assert function. So that's just classical debugging. I can reset the debugging session, and I can also set breakpoints, right? So instead of executing over my function one step at a time, I can just directly jump to my breakpoint and see what's the state at my breakpoint. Another cool feature, and that is more for the advanced users, that is we have full support for bytecode level debugging. That is, let me restart the debug session and right-click on my current stack frame, and I can open this disassembly view. And this disassembly view brings me to the bytecode of my smart contract. I can see on the right-hand side in the right column, I can see my operations. I can see, hey, there's a push operation here, there's an mstore operation, and I can execute over these bytecodes one small step at a time, and actually see how my stack here or all my EVM state changes while I'm doing that. So sorry, I clicked the wrong button here, but this is, so next line will push the constant hexadecimal 40 onto the stack. Let's observe the stack, and we can actually see that it pushed the constant 64 onto the stack, which is a bit unintuitive, but this is decimal representation, and in our bytecode we have the hexadecimal representation, but they are the same values. So next operation will store something in the memory, and so on. So that is all I wanted to show you today. Obviously, there's a lot more that you can do, but I think that's enough for like a small session.
Thank you so much. I think these features can save a lot of time for both auditors and developers. Thank you for that. So how can our listeners try this tool and potentially get involved in the beta testing?
Oh, that's a really good question. So first of all, at Runtime Verification, we are committed to developing open source software. And at the moment, we are in the final stages and doing some beta testing. We have a closed beta. The goal of this beta is just identify any roadblockers before we open source it. But the open source release is just like some weeks away. It's definitely not months away. For the closed beta, you can go to our website, symbolic.runtimeverification.com. There's a button that brings you to a waitlist formula. You can sign up there to get early access, or you can just wait until the open source release. Or we have put together a public demo that is just available through a website. Go to try.symbolic.runtimeverification.com, and it will bring you to the website that automatically loads Visual Studio Code. It's a very limited demo in the sense that it only allows you to debug wrapped ether and not any custom written code. But if you just want to get a feel for the usability, for the user experience of the debugger, then that's the right place to start. Nice thing about this online demo is that it actually has some advanced features that I didn't show you before, and that is one of the features is can give you very strong correctness guarantees, that is symbolic execution. So the online demo will actually let you debug also functions with parameters without specifying what these parameters actually are, without specifying a concrete value before execution. And what it does then, it just explores all the reachable code paths. That's a super strong feature, but I think we're going to have another video on that.
Thank you for your time, Raoul. I want to say to our listeners, sign up for the waitlist. The tool will be soon, and stay secure.
Thank you, Gregory.
Thank you.